we have Sachin from the Nirmata team. He's working as a solutions architect for us. And he will be talking about some very interesting topic. You must have heard about shift left, but we will be talking about shift down and understand how it's impacting your organization, what is the difference, and feel free to ask any questions at the end of the session. Please, Sachin.
Hello everyone. Thank you, Rashmi, for introducing me. So the topic is pretty much what you see here, like how we do a shift down approach to an SDLC life cycle, right? So before we start, I just want to set some context and also wanted to understand just idea I want to take, like how many of you are using Kubernetes in production right now, and how many of you are actually working on heavily on Kubernetes? Okay. Okay, and how many of you are into the security domain or are taking care of certain aspects of security in your organization? Nice. Okay. So before I start, let me just introduce Nirmata in front of you and what it does. So Nirmata is actually founded. It's founded in 2013 and headquartered in San Jose. So we were into a domain of building all the policy and governance tools in the cloud native domain. So we have a very deep expertise in the area of cloud native policies and governance for the platform team. So we are the main creators of Kyverno, and we started with building Kyverno, and then we have donated it to CNCF. So that's where the whole journey began, and currently more than 500 global Fortune customers are part of Kyverno, and they are using Kyverno in their environments, right? So when we talk about policies or governance, right? As you already know, right? There's a significant shift of how the organizations are approaching towards infrastructure, security, and all these aspects, right? So definitely there's a great shift towards platform engineering, right? Where people are now building more and more wrappers, more and more abstractions on top of infrastructure, so that developers don't have to actually think about how it is going to run or how it is going to work in the underlying infrastructure, right? So that's where the platform teams comes and they actually build these platforms so that it is abstracted out from the developers and all the complexities are being removed from the developers side, right? So the idea is CNCF has done some research about it, and it find out around 80% of the enterprises by 2030 will be shifting towards platformizing the teams, and they want to abstract out most of the complexities of the infrastructure and the security from developers side, right? So whenever we shift towards platform engineering, right, one of the major factor that gets introduced is the misconfigurations, right? Because now it's a central team, right, and now it's a central platform which actually take care of all the provisioning and all the configurations of a underlying infrastructure, right? So definitely there is going to be a misconfigurations that come into picture, right? So the idea is as soon as these enterprises are moving towards platform engineering, definitely there will be misconfigurations that will be introduced into the system, right? And to cater that, there are, as you can see here in this graph, right? Kyverno is being used by most of the organizations, and these are a couple of organizations to just mention. And if you can see here, the graph, it clearly shows like how Kyverno is moving upward with the upward trend, and also we have done some comparison with the OPA, or we call it as an open policy agent, right? So definitely we have around 1.4 billion image pulls from GitHub, and we have 3.7k stars in GitHub. There's a very big community which is contributing to Kyverno. So we have around 300 plus community contributors, and we have around 2k. Now this is not 2k, it's more than 3k. 3k Slack members that have joined us, and they are collaborating with us. We have curated policies being defined for these infrastructure, which is close to 350 in number now, and it is ever growing, and we are keep on adding new policies that will actually increase the posture of security posture of all the workloads.
Sachin, one correction here, it's 3 billion downloads.
Yes, yeah, definitely. So this data is being bit old now, because now we have reached 3 billion, and definitely like it's ever growing, and it will again grow to higher numbers, right? Now, when we talk about misconfigurations, right? So there's again a CNCF survey that happened, and it was find out like there will be an 180% increase in the security issues with all the platformization that is going to happen in the near future, right? And out of these 180% of security issues, 90% are reported as a security incidents, right? And the major leading factor to all these security incidents or security issues is going to be the misconfigurations, right? So definitely there is a good amount of chance that once organization move towards platformization, definitely a lot of new vulnerabilities or new security issues will be introduced into the system, and how to cater to all those security issues, or how to channelize or gatekeep them, and make sure that your infrastructure is compliant according to the security, and it is not receiving any security incidents, right? So how Nirmata prevent all these things, all these misconfigurations and security issues into the environment? So at the core of Nirmata, we have admission controller, what you can see. So this admission controller is nothing but Kyverno. So Kyverno works at the heart of Nirmata, and it actually takes all the requests from the API server, right? And it enforces these policies in the infrastructure, right? So typically when we talk about Kubernetes, it enforces all those policies that we are defining in the Kubernetes environment. Then apart from this, now it's not just Kubernetes that we are working on. We have extended our functionality even beyond Kubernetes, and now we are moving towards the shift left approach also, where we have the pipeline scanners. So what these pipeline scanners will do is it will actually scan for your IAC code, Docker files, and the configurations, the Kubernetes manifest, to check whether these manifests or these configurations that you have defined comply with the security posture or not, right? So you can have policies defined for these IAC codes also, and now you can actually block, or you can actually keep them, right, at the time when you are building or when you are writing these codes, right? So definitely scanners are going to be a major factor, where you can introduce a lot of security best practices and a lot of security guardrails in the early stages of development itself, and reduce number of misconfigurations that will happen in production by deployments, right? And apart from that, in the future roadmap, we are also going to introduce a cloud controller, admission controller for cloud, where we can actually help organizations running these cloud workloads in the cloud environment, and we can scan those also, and we can provide the security guardrails against these resources that are being deployed to the AWS. So currently we have worked with ECS, and we provide the security scanning features for ECS, and also it is ever growing. We are keep on adding a lot more other services into the functionality, and definitely you will see it in the future. Now let's talk about how Nirmata works and what all components are there in Nirmata, right? So typically, if you see here, this is the typical workflow that usually goes whenever you do any API request to a Kubernetes environment, right? So first of all, it will be checked for the authorization, whether the person or entity who is actually requesting the API server is authenticated or not, right? And once the authentication is done, then there are three phases in which the actual validation happens. One is the mutating admission. So when you talk about these three components, these are the webhooks, right? These are the webhooks in the API server which you implement, right, to actually do some action on top of it, right? So one is mutating admission, then other one is schema validation, and then the other one is validating admission. So Nirmata typically caters to two webhooks, which is mutating admission and the validating admission, right? So whenever a request is being submitted to an API server, it goes through these three processes: mutating, schema validation, and then the validation admission, right? And under the hood, we have these components which works in conjunction with the engine, which is webhook monitor is there, the search manager is there, report controllers are there, and the background controller is there. So you have heard recently, like the past presentation, where the background configuration was there, whether you want to run your policy for the existing resources or not, right? So that's where this background controller will take care of those things, where it will run these policies against the existing resources that are already deployed in your cluster, and it will generate reports according to it, right? So all these components will work in conjunction, and it will create the reports. The background scan reports will be created, the admission reports will be created, the policy reports will be created, and then you can visualize these reports in, using either you have a policy dashboard which will show you all the policy reports, or you can have it in the NPM, right? Some of the top use cases that typically Kyverno solves is the pod security, where you want to introduce a baseline security to your pods that are getting admitted to your Kubernetes cluster. Your workload security, right, where whether your workloads are compliant with as compared to the security posture that is being defined in your organizations. There are certain best practices, policies that we have defined in terms of how your infrastructure should be deployed, and what are the security compliance that you should be maintain in your infrastructure. There's a huge policy sets that are defined for the micro-segmentation. When you talk about multi-tenancy inside Kubernetes, right, where it works in conjunction with multiple customers and they are all in a multi-tenant environment, right? Then micro-segmentation comes very handy, because you don't want any kind of a noisy neighbors in their environment, right? And that's where this micro-segmentation on the network policy level and on the namespace level will actually help you in segmenting all those things, right? Multi-tenancy policies are something which I told, like you can have a network policies defined for these namespaces in a multi-tenant environment, right? Then we have a resource optimization. So recently we have collaborated, and there is one webinar that is going to happen, where we are going to talk about how you can have a policy-driven resource optimizations inside your infrastructure, right? And then the software supply chain security, where the pipeline scanning and all those features will come into picture, right? Now, I think Shubham has already talked about a few of the differences between OPA and Kyverno, right? But just to extend on that level, this is the feature comparison between OPA and Kyverno, and where OPA lags, right? So definitely, if you see here, the adaptability is something which is definitely a challenge with OPA, because you have to learn new language, and whereas in Kyverno it's a universal language YAML that you are going to work with. Resource validation is definitely present in both the products, but when you talk about resource mutation, right, definitely Kyverno is much more mature in that terms, and as compared to OPA. And also if you talk about other features like resource generation, then policy exception reporting, and validating the non-Kubernetes resources, that's where Kyverno standouts, and it also integrates with the supply chain security, whereas OPA doesn't have that feature yet, right? So we are definitely ages ahead of OPA in terms of the feature set that we have provided, and definitely it will help in help organizations grow much better and much in a secure way, right? So,
I have one question. Could
yes.
you elaborate on the low-code policies, like what exactly?
Sorry?
Low-code policies.
Yeah, so when we talk about low code policy, so definitely when you are working with your environments, right, there are certain cases where you have to write a custom policies for certain resources, right? That's where the things started getting complicated, right? When you write these policies in Rego, right, your policy will become too huge that it is very difficult to maintain. Right? Whereas with YAML, it's a simple construct, right? It's very intuitive, and you will be able to pinpoint where exactly the problem is, right? That's where the low code policies will actually make sense. Where when you are defining these policies in a YAML construct, it is much more cleaner in terms of visualization, in terms of intuitiveness. Whereas in Rego, it will become more complex and more hard to read, right? So that's where like this standouts as compared to OPA, right? And any other question?
Yeah. How does Kyverno creates automatic network policies?
Yes. So automatic network policies are part of a generator resource kind, right? So definitely you can have an automated generation of network policies whenever a new namespace is being created, right? So there are multiple use cases in the multi-tenancy environment itself, that whenever a new namespace is created, automatically certain network policies should be deployed, right? So that's where Kyverno can help you. It will help in generating those resources automatically on certain action, right?
Like on what basis, suppose I have deployed a new namespace, like it's got 10 elements. How does Kyverno knows like my request is going to another namespace, or like my request is coming from end user? So it should have some logs to take that and it should create. So on what basis it's created?
Yeah, so whenever you are creating a namespace, right, what happens is it will go through the whole process of the life cycle where the request will be authenticated and the mutation admission will start happening, right? So that's where this action, you define in the generate policy that on which action you have to create these policies, these network policies, right? So that's where you define in the rules saying that whenever a new namespace is being created, right, you have to deploy this network policy. Right? Similarly, if you are creating a new namespace, you have to create some registry credentials, right? So that's where it will check whether a new namespace is being created, because API server knows everything, right? Whatever admissions that are happening will happen on the API server level, right? That's where these webhooks will come into play, and it will check what kind of a resource is being created, and based on that, it will take the action on the policy, right? So it will apply those policies based on the action that you are doing on the API server, right?
Like we have CMS and another network. So CMS one capability of problem. Like they have a way where they have like what are the requests coming, everything we can send to them. So on open source techniques, then for bubble logs, CMS will automatically create the network policy. So it has this source like the logs. As you are saying, like API server or web, we need to mention like network policy. But how can application or web API server was like without request? It takes some time. Right? So there the CAC approach what you say is like it will create network policy automatically, but how does it know like request or request? Like you don't know the source and the destination where it goes, the new name is created. Unless you test it environments also, it will be not there. So production level, how does it?
So typically all these configurations should be driven through a code, right? So that's where your code defines. So certain aspects like generation of a policy, right? That is something which is automated, which is not part of your code, but these policies are part of your code, right? And when you're creating a namespace, that is also part of your manifest, right? So whenever you're creating these namespaces, right, you definitely see when you're deploying any application to a namespace, you should be knowing that this namespace should be present, right? And that's where your workflow will come into play, where you have to define first that the namespace has to be created, right? And now once this,
what I feel is asking actually where the Kyverno engine gets into the picture, basically. So
is this
that's
the
how
question?
actually it is identifying, right?
The source of creating the network policies. So
Because Kyverno engine will trigger that policy ultimately. So yeah, this diagram.
So here if you see, So your request will come through this stage, right, where the mutation admission is there, right. So what it will do is, here it will check for your resource that you are creating, right, and on the rule that you have defined, saying that for a kind namespace, right, whenever a kind namespace is being created, do some validation or do some generation on top of it, right. So you have already seen one example of mutation and the validation, right. At the same level, you will also do a generation, right. So that's where it will happen on this level where it is getting admitted, and then a mutation will happen, because it's all kind of a generation, right. So generation in itself is kind of a mutation, right, which happens at the runtime, right. So that's where these namespaces and the network policies will be created. Whereas once all these things are created, then the validation admission will come into play, and it will validate whether it is passing other policies that defines for a resource or not, right? I hope this answers your question. Now, let's talk about few of the use cases and on each level of working in the organization, right? So we have like CI/CD pipelines, we have in-cluster configurations, right? So at the security level, what all things that Kyverno actually caters for is like pod security is there, workload security is there, granular RBACs are there, right? The workload isolation where you define the network policies and you define the micro segmentation, right? So all those are the typical use cases in the multi-tenant environment. Image signing and verification, which Zeta is already using, right? Then we have a workload identity. So all these features are from the security perspective, where you want to introduce some kind of a guardrails and some kind of a policies around it, right? Whereas when it comes to operations, there are multiple use cases like namespace as a service, right? Where you want to provide a platform where a developer can request a namespace. Automatically, these namespaces will get created in your infrastructure, underlying infrastructure. Then there is a cluster as a service. You want to inject a custom CA certificate to your namespaces, right? Then automated resource generation, conditional patching of certain resources based on the inputs from the security teams, right? Then injecting of the sidecars are there, right? And the stale resource cleanup is there, because there are multiple areas where, let's say, if you are running some job, so job is something which will take action and then it will stays there, right? Saying it is completed, right? And apart from that, there are multiple resources where you don't want to actually run it and you want to clean it up, right? So that's where like stale resource cleanup policies will come into play and will do the action, right? On the cost side, we have a pretty good development in the cost areas where we are providing policies for the resource optimization also. We have a pod request and limit policies, like automatically generating all these requests and limits for a pod, or validating these requests and limits are being provided for a given pod or not, right? Then we also have a policies which defines the HPA if it is not present. Automatically it will create an HPA, it will create a VPA, vertical pod author scaler, right? Then there is a namespace quotas that it will define automatically whenever a new namespace is being created, right? There are other mutations in terms of labels that you need to add, annotations that you need to add to your resources, right? Then the auto scalers that I talked about, like HPA, VPA, right? So these are typical use cases which where Kyverno actually helps platform team in generating these resources and complying with the security. Right?
So how is injecting the sidecar containers? How Kyverno is different in terms of STO or service meshes?
Yeah. So STO and service meshes, they have their own set of implementations to define the sidecar injection, right? Where they have a flag called inject sidecar and you have to make it true or false, right? Whereas in Kyverno, what it does is we have a generate policy which will actually generate a resource for you based on certain template for a sidecar injection, right? Let's say you want to inject a sidecar for doing some gatekeeping work, right? For an application, right? So that's where these istio sidecars or the service mesh sidecar will not help you, because they are typically bind for their product, right? It is not generic enough. Right? It won't create a sidecar for other tools or other use cases. Whereas Kyverno can help you in creating these sidecars for the custom use cases also, and you can inject it at the time of at the runtime, right? So those use cases where STO and service meshes are working, those are very specific to them, right? Where they deploy their workloads to it.
Both can do the like continuous monitoring also.
Yes, yes. Right. Now, we talk a lot about platform teams and how security postures can be maintained and how policy helps in maintaining these security postures, right? But let's take a step back and let's understand how security works on each level, right? So, have you guys heard about say, shift left, shift right kind of security measures, right? So, typically when we talk about shift right, what happens is it runs at the time when you have deployed something, and at the runtime it is giving some outputs, right? So there are multiple tools that actually works in the shift right approach, where we have Prisma, we have Wiz, we have Aqua, right? So what it does is they give you a runtime vulnerability scan, and they provide you the reports around it, saying that these are the components or these are the resources which are compliant and these are the resources which are not compliant, right? So those are at the time when resources are already being deployed in your infrastructure, right? The damage is already done and now you have to fix it, right? Whereas shift left, when we talk about shift left, it is more on the SAC, where you define the dynamic code quality of your code, right? Whether it is vulnerable or not, and whether the quality of a code is matched with the level of set levels that is being defined in the organization or not. So Sonar type Snick is some of the tools that maintain these dynamic code analysis, right? But nobody talks about the shift left approach of IAC, right? Or whether the Docker file that you have written is optimal or not, right? Or whether the Kubernetes manifest that you have written is okay or not in terms of security or not. Right? So that's where Nirmata is playing its part, and it's actually moving one step further, and it is introducing a new concept called shift down approach towards the security, where we embedded all the features, all the capabilities of Nirmata into the platforms, right? And we enable platform teams to actually integrate all the security postures and all the best practices in their platform right from the day one. Right, so that it will proactively enforce all the native tools that are using these IAC tools and other tools. Right, it automatically check and remediate certain dev pipelines and give you suggestions on top of it how to remediate those violations that are happening, and also make sure that the production environments are much cleaner. Because one thing is definitely correct, that if you catch certain vulnerability right at the time of SDLC, right, is much more efficient than you are doing it at the time when it is already deployed in production, right? Because the cost that is involved in fixing the issue at the time when it is already deployed in production is very huge as compared to the one when you are doing it in the actual development, right? So that's where this shift down approach will definitely help teams. One thing is reducing the cost of fixing the issues, and second thing, making sure that all the deployments that are happening to your production environments are much cleaner in terms of security, right? Now let's talk about so how this whole thing got evolved, right? And from where it is coming, right? So typically when we talk about cloud security evolution, if you talk about 10-20 years back, right, how things were deployed inside or how these applications were run. So there were bare metals on which it will run, right? So that's where developer used to code. There were SAST and other shift left tools which were actually scanning for your quality of a code. So source code was scanned definitely. This was one security aspect that was already there. And then it will get deployed to your servers, which is in the data center. But there is nothing in between which is actually scanning or doing any security gatekeeping, right? So operations teams is used to take care of all the deployments and all the aspect of automating those parts. But security team is typically involved at the time when everything is done, and at the runtime what is the security posture. So it is pretty late to identify anything that is wrong in the system, right? So definitely there was a lot of efforts, lot of cost that got involved at that time, right? Now, after certain time period, it get evolved, right? And then there was a source code and there was a IAC that got introduced, right? Which actually automates the whole process of provisioning your infrastructure, right? So definitely SAST was already there, right? The vulnerability scanning come into picture, the IAC scanning come into picture, right? And people started starting tapping on more of the capabilities of developers that they are doing, right? And how you can measure the security at that level, right? But still, there is a runtime security that will happen, and there is a separate team who is maintaining the whole platform of abstracting out these infrastructure from the developer, right? Now, this is at the time when cloud got introduced, right? Now, things did became much better as compared to what it was there in the data centers level, but still it lacks few of the concepts that we talk about, which is now things are shifting towards cloud native, right? And people are talking more and more about the cloud agnostic level, right? Where wherever you deploy your application, it should run, right? It should not be dependent on any cloud or any infrastructure, right? So that's where the complexities started getting multifold, right? And it is totally dynamic now, right? So that's where the source code was already there, IAC was already there, but Kubernetes manifest also got introduced. Now, you have to have another tool to actually go and scan for these Kubernetes manifest, right? So definitely for Kubernetes manifest, another scanning has to be done, right? And then there is another concept called GitOps that came into picture, right? It's a pretty recent, like probably 5 to 6 years back, it got introduced into the organization, and people started adopting that way of doing the deployments, and things started getting more worse because the misconfigurations are typically that started getting introduced in the GitOps way of doing things, right? And again, new teams were formed, new platform teams were formed to actually cater to all these automations and deployment of your resources, right? So new things got introduced like admission controls, security guardrails are there, then the policy of code, policy as a code is there, right? So that's where the things are shifting towards the down approach, right? So when we talk about shift down, right, it came from this perspective, right? How we are shifting, how we are evolving, right? So typically people were doing the security scan at the shift left level, right, and shift right level where it was done at the runtime. But nobody talked about shift down approach where now things are more dynamic and new resources are getting introduced into the system, right? How will you cater to those resources, right? So definitely you need some tool or some functionality which is comprehensive enough to take care of all these things, right? So that's where Kyverno comes into play, or the policy as a code comes into play, and it actually caters to all the aspects of the security and how you scan these resources and how you make sure your guardrails are intact in your systems, right? Any question in this slide or any thought?
Before pushing, like we build a CI, we push image to any instance, right? So does Kyverno also helps in signing that image? Like
Yes. So Kyverno definitely helps you in signing these images and validating these images. So Kyverno will actually be responsible for validating these images, right? But for signing purpose, definitely there are multiple tools that you can use. Trivy is one tool for scanning your Docker images. Then Cosine is there for actually signing these images and pushing it to your registry, right? So all these artifacts are being created as an artifact and pushed to your repositories, right? So once these resources are pushed to your registries, then Kyverno is the one which actually take care of validation. Yeah.
Currently,
Yeah. Sorry. My throat got totally screwed up. Yeah, so when we talk about shift down, right? So like all these good tools that are there on the shift right side, right? Like Prisma and Wiz, they only talk about runtime, right? They will do the scanning for your cloud resources also. They will do the scanning for your cloud native resources also. But they will not talk about how it got introduced in your system. Whereas shift left, it will do the scanning on your code, right? It will check whether your code is compiled and whether your code is passing the quality checks or not, right? But it will also not talk about the fact that when it is getting deployed, whether the integrity of that particular code is intact or not, right? So that's where these two has to be converged somewhere, right? And there has to be some tool which actually take care of all these use cases and bring it to one single like tool, right? So that's where Kyverno helps, right? What it does is it complements all these two sides and it brings down to a single like unified solution. I hope I answered.
Yeah, one more question was like, let's say a runtime issue happens. So does Kyverno provide some traceback because of this test failure? Does it give more insight?
So at the runtime, whenever a violation is happened, right? So one thing is Kyverno will not even allow that violation to happen itself, right? Because Prisma and Wiz, what it will do is the damage is already done. Now they are just scanning it and intimating you saying that this is done and this you have to fix. Whereas what Kyverno will do is it will not allow you to do that damage itself. It will block your resources at that level itself, at the runtime itself, and saying that you are violating these security policies, right?
So it works along with shift left, shift right, and shift out. So all three together will work.
Yes. So Kyverno actually complements shift right tools also, and it complements shift left tools also, right? And it unifies everything into one approach of how things can get embedded inside your platform itself to make sure that your security guardrails are intact, right? Now let's dig more deeper into how the security enforcement can be done on each stages of SDLC, right? So typically when we talk about SDLC lifecycle, what all things are there that happens? Can anyone tell? Any one person can actually chime in and represent everyone.
First of all, you have planning phase where, from a security perspective, you know, then it goes to prototyping phase, then it goes to development, and after development, you have testing phase, and after testing phase, definitely there are security gates involved. Then deployment and maintenance.
So definitely, so planning and then architecting those solutions will come into place first, right? And once all those things are done, then it will go to a development phase where people start working on it, start developing it, right? So that's where your version control and all those systems come into play, and you start committing your code, right? Now, once you commit your code, there has to be some security check on top of it, right? And what are those security checks? Whether they validate the configurations, changes for each commit, right? Using GitHub Actions. So that's where your GitHub Actions will take into play, and it will do some validations. And for example, whether you are introducing some credentials in your Git repo, right? It will check those, right? Then it will also check for certain best qualities, right? So all those things will come in at the phase where you are actually start committing your code, right? Now, what is the next phase? Once the commit is done and your SAST and all those checks are done, right? Then it will go to your build phase, right? Where you will actually start introducing the build life cycle and you start building your artifacts, right? Now, what is the security aspect here? You have to sign these artifacts. You have to make sure that from where the builds are happening is authentic, right? So that's where like verifying, signing and attestation of all the images or artifacts come into play, right? Now, once this is done, right, you will deploy this, right? So now, what can be a security aspect that can be introduced at the time of deployment? Can anyone tell? Admission, right? So that's where the validation of your configurations will happen. Kyverno comes into play and it will validate those deployments whether it is passing the policies or not, right? Now, once the deployment is done, what will happen? Run, right? And at the runtime, the shift left, shift right tools will come into play, right? Where they will start scanning, detecting new issues that are getting introduced into the systems, right? Or the background scannings that are happening, right? So that's where. So these are the levels of SDLC that happens, right? And how you introduce security aspects on each level, right? Any question till this? Anyone has any doubt? So you understand like how we introduce security at each level, right? And how important it is to actually maintain the security at each level, right?
I think she has a question.
Yeah.
So when you say commit, right, those validation happens after the PR gets merged into any developer main run or immediate code once it's happening, then you need the validation.
So there are two ways of doing this. So one is at the time when you're actually doing the commit, it will run on your local, which is called Git hooks, right? GitHub hooks, right? So what it will do is it will do some pre-flight checks, right? Whether you are introducing any credential to your commit, right? So it will check that and it will block that, right? That is one case, right? The other case is as soon as you commit your code, right? It will start running the SAST pipelines around it to check whether your code quality is correct or not, right? So there are two aspects. One is at the local machine, at the time of local machine. Other one is at the time when you have actually committed the code and it is there on your version control, right? It will definitely at the pipeline level also you will do this, where you will create a PR and it will run certain checks around it, right? So that's where this code commit will come into play. It will run for your SAS like IAC code. It will run for your Docker files and the Kubernetes manifest to check whether those are complying with the security or not. And it will take an action on top of it. Whether the scans are passing, then merge the PR. If not passing, then you fail the PR itself, right? So that's where this first level will come into play. Any other question? Now let's talk about few of the benefits of shift-down approach and why we need this, right? So definitely a proactive security will definitely come into play by integrating these security measures at each operational aspect, right? It will help like aspects of Kubernetes organization. They can proactively identify these security vulnerabilities in their system and they can mitigate it way before actually getting introduced in the production environment, right? So things, the time to actually resolve will drastically reduce because it is happening in the early stages itself, right? Second thing is adaptive security, right? Since the landscape is totally changing and it is becoming more dynamic, right? More complex. Definitely there has to be a functionality which adapts all these dynamic changes and work in conjunction with that, right? So that's where the automated security controls can adapt to these dynamic change nature of Kubernetes environment and ensure that these security policies are consistently enforced on each level, right? Then we have an improved collaboration. Why? Because now developers know in beforehand itself that what they are introducing in their system, right? And they can take action on it at the time of the development itself, right? Instead of just deploying anything and then working on it, because it will definitely take time and it will definitely increase the cost also to fix this, right? So that's where the increased collaboration will happen and people will start getting more and more feedbacks way earlier than later, right? Then we have a enhanced visibility in terms of like how your security posture is there overall in the organization and how you can make it more better or how you can improve it. right? So all these visualization in terms of continuous monitoring of your resources, continuous monitoring of your policies that are getting deployed or getting enforced on these resources are performing and making and detecting the quick response to the threats that are happening, right? So overall, when I talk about Nirmata, like how Nirmata helps in this whole aspect of security and governance, right? So as I already told, right, at the heart of Nirmata there is a policy as a code, which is Kyverno, right? There is an admission controller, which takes care of all the admission requests, right? We came one step further and we started introducing it in the pipelines, right? By providing a pipeline scans. We are also started introducing in the clusters where we are where we are actually scanning for the cloud resources also like ECS, right? And other resources, right? So that's the whole landscape that is changing, and with that we provide a central visibility in terms of how your organization is doing in terms of the governance and security posture. It also helps you in collaborating in providing these policy enforcement and the exception management that happens for a particular policy or resource, right? It also helps in collaborating or making the collaborative workflows around the teams. For example, security team works in totally different manner as compared to platform teams, right? And the job roles are totally different, right? So definitely there has to be some collaborative, some bridge between these two teams so that they can collaborate in conjunction and there is less hindrance in the whole process, right? So that's where these collaboration workflows will come into play, and it will help you in streamlining all those workflows of how you remediate your violations and how you make sure your infrastructure is compliant enough, right? Then we have remediation recommendation, as I talked about. Let's say if you have deployed some resource and it is violating certain policies, right? You will get a remediation recommendation in terms of what you can fix in this particular resource which will make it more compliant, right? So all those remediation recommendations will be provided, right, from the Mata platform, which you can actually help you in remediating all these things way quicker than doing it through a manual process, right? Then we have a compliance reporting where you can actually have a regular scheduled reports in terms of how your infrastructure is compliant in terms of security, and typically this will cater mostly to the security teams where they need these compliance report on a regular basis for the auditing and stuff, right? So typically the idea is to have a security and SecOps automation, supply chain security, operational best practices, resource optimization and governance, risk and compliance, and the overall tool, right? So that's where we come into play, and we try to make sure that a unified tool is there which will cater to all these requirements for a given organization. We do have a very good integrations with certain open source and certain tools that are there in the market. We integrate very well with all the cloud providers. We have an integrations with DevOps tools like GitLab is there, GitHub is there, Jenkins is there, and Terraform is there. We have a collaboration with the cloud native tools like Argo CD. We are collaborating with Upbound to create certain feature sets in Kyverno where we can actually leverage the automation of creating all these resources and making it more seamless. We have recently collaborated with KubeCost in defining the policies that will help you in governing the cost optimization in your organization and make sure that your resources are optimized at that level, right? Then there are certain tools like in the IT security domain like ServiceNow, Verifying, and Datadog, which will help you in visualizing and making sure that your systems are working well with the conjunction of these tools, right? So all done. The last thing that I want to introduce is how pipeline scanning actually works and what all things it introduces in this system, right? So typical workflow, how the pipeline scanning works. So if you see here, we have two levels. One is the platform security admin, which will actually be responsible for writing your policies, right? To make sure the resources are compliant enough in terms of security, right? So that's where they will define all these policies in a YAML construct, right? For image registries and for the manifest, right? And they will put everything, or they will start committing everything to a central repository, which is called central policy storage, right? Where all the policies will reside, right? Then we have another workflow where the DevOps users will be using these CI/CD tools to actually build and run these artifacts in the environment, right? So that's where the CI pipeline will come into play, where you will actually start using the NCTL. Now NCTL is a binary or is a tool that Nemata has created, which helps you in scanning certain cloud resources like Kubernetes manifest are there, Docker file is there, IAC code is there. So it's a open to download software that you can actually go and download and you can test it out. The only thing that it will not do is publishing these results to an NPM platform, right? Because that is a paid feature. Whereas it is free to download. You can go and you can play around with this. What it will do is it will actually refer to your central repository where all the policies are defined, and will start validating these policies against your code that you have written, right? And once that NCTL scan happens, so you can actually hook this step with your GitHub Actions or CI pipelines, and make sure that whenever a new commit has happened, it will automatically run those scans and it will take action on top of it. Whether let's say if you raise a PR for a given change, right? And this pipeline scan works, right? And it detects some issues in your code, right? Then it will take an action and it will decline that PR. Or otherwise, if it passes everything, then it will accept that PR, and automatically those PRs can be merged in the respective branch, and you can go to the further next steps where these reports, whatever is being generated, these scan reports will be published to your NPM portal or NPM platform, and you can visualize like where the violations are actually happening, right? Just to showcase this, what I do is I show you how this whole things look like, right?
Sachin, how long?
Just a moment.
Okay.
Almost done. Yeah, so this is the NPM platform that I'm talking about, and if you see here, this is the section where all the policy reports will be generated, and it will be shown with like how your resources are compliant in terms of policies, right? And there is a section called repositories. So this is where you will see how the pipeline scan works and what are violations it is creating in your code report, right? So for an example, if you see here, it has scanned certain report, and it has detected certain violation in a resource, right? So for example, it detected that the Docker file that you have written is not compliant enough, right, as compared to the best practices, right? And it suggests some changes to it, right? And similarly, if you see, there are a Terraform code which actually has some compliance issues, saying that ECS containers should not have insight enabled, right? So container insights has to be allowed, and that's where like it is showing like violation, and you have to do that change, right? Similarly, it also works for the Kubernetes resources, right? So if you see, these are the Kubernetes manifests, where it validates in front of all the Kubernetes manifests that you have defined, and will suggest based on the policies that you have defined whether it is compliant with the policies or not, right? So this is one example, and how typically you integrate this. So I have a working example of this GitLab pipeline which actually works with NCTL. So typically in this pipeline you can see there is a folder called policy sets where I have defined all the policies that has to be validated against the resources. Then I have a deployment which contains all the resource manifests, right? The YAMLs that has to be deployed, right? And then we have a sample application which has a Docker file which will be scanned as part of the NCTL scan. So typically the GitLab pipeline looks like this. right? So what it does is, there are two stages. One is it will install the NCTL finally into the stage, and then it will do the NCTL scan, right? So this is where it is doing the NCTL scan. So since I'm using the enterprise version, I'm just passing the token in front of it so that all these scans will be processed and will be published to your NPL repository, and you can define the path or policy path which you have to run against these resources. Yeah.
So this HCDL scan, does it require access to the API server?
No, it doesn't require any. So how it works typically is, have you heard about Kyverno JSON policy?
Yes.
Right? So it works on that, right? So it doesn't need any API server to be running. What it does is, it is just, what to say, it's rendering certain manifest against the policy that you have defined. So it's a JSON policy that you define, and it runs against it, and will show you whether it is compliant with that policy or not. Right? You can have, so YAML constructs work in this way, that what is the target state and what is the desired state, right? So that's where you define that desired state in your policy, and then run against your manifest and see whether that desired state is maintained or not, right? So it doesn't need any API server to be running, it just run against your code and it shows whether it is compliant or not, right?
How much time does it take to scan?
So typically I have ran a couple of scans, and I'll just show you one of them. But typically it also depends on number of policies that you have defined for a given resources, right? So as you keep on growing your resources or your policy sets, definitely it will take some time. But yeah, you can run it in parallel with your bids so that it will take lesser time. So as you can see here, it took only 2 minutes for me to run this whole scan report, and it has published the result in the NPM repository or the NPM platform, right? As you can see. So all your you can tie these repositories with your NPM, and it will start showing the results each repo wise, like how your repo is compliant with the security posture. Right? So
Does it have any exceptions as well? Exceptions as well, if a product is already has to be done in a particular way. Then in this way, if you are using the same policy for multiple agents or multiple level learners, it will show a violation of the report.
yeah, so for those cases, you can definitely have a exclude. Policy exception will not be a proper terms in terms of pipeline scanning, because those are time bound, right? And
But in this scenario, if I integrate it with GitHub Actions, it will scan it, it will say 3 years.
Yeah.
And the PR will not be able to pass or it will not go. So how do you handle
so definitely we can introduce as exceptions to these policies, and we can define like for which resources it has not to be run.
Same like the policy that they are applying.
Yes. So same policies what you are defining for the running resources, you can even use for the pipeline resources also.
So exclusion of resource or exclusion
Yeah.
of certain.
Yes.
that has to be on the policy level?
Yes, it has to be on the policy level. So if I just show you one of the sample policy here. So if you see here, let's check for any one of the policy.
So NCTL, I'm not sure we did this one, but it don't have that like it will be good just a kind of review or something. You don't have that parameter kind of an action exclude or action exclude. And you can give the policy name, whatever the violation
Yes.
or whatever
Yeah.
it is.
So definitely those features are
Now the exclude will work, right?
yes. So as part of the new feature releases, we have taken care of all those feedbacks, and we have added it to the mainstream release. And now you can have those exclude flags also being defined in the NCTL scan command itself, and you can exclude certain resources. Yeah.
This is more from the line of infosec driven
Correct.
configuration.
Yes.
Where that exclude is kind of needed.
Yeah.
At times the configuration become too long for infosec even to handle.
Yes.
In those cases, you can't keep excluding.
Yeah, definitely you
some
can't keep on.
configuration kind of
Yes.
something which
they can have like okay, for certain repos I can put these uses.
Yeah, yeah. So all those things can be maintained in your central repo where you are actually maintaining all the policy sets, right? And then those policy sets can be generic enough or can be very specific for certain repositories. And all these things you can actually handle through Jenkins libraries, shared libraries, or you can hook it with your GitLab CI, right? So there are templates that you can use in GitLab CI which will actually help you in templatizing for all these things and automatically get it applied to each and every pipeline, right?
I think we should wind up.
Yes.
Yeah.
So I think one last question I have. If you go in the NPM, you've shown quite a few policy violations, but you also mentioned earlier that you have auto remediation. For example, where is the
Yeah. So let
So
me
Sachin, if you could repeat the question so that everyone can understand what the question is.
So the question is like I did mention that certain violations will be there for our resources, but how will you get to know like how you can remediate those violations, right? And how it will work, or how NPM will suggest you those remediations for a violation. So if I quickly show you one use case.
Sometimes, I mean, more of this, sometimes health charts are also maintained by developers. There might be a common in those cases, will they be able to understand these and even remediate it themselves?
Yes, definitely.
That kind of report is something like that.
So you can definitely give access to your developers also to see these policy violations. And if you see here, right? So there is a view remediation diff, right? So when you click on this view remediation diff, it will actually give you what things you can introduce in your manifest to make sure that these violations are getting removed, right? So it will typically give you the suggestion like you can introduce these flags to your manifest so that it will remove that violations in your system.
Are there any instructions or a report kind of something which also talks about these and reply they are not?
Yeah, if I just take any one of them.
It was supposed to be 12.
So as you can see here, it definitely gives you a description on why it is failing and how it can be resolved, right? And also in the policy reports, when you generate a policy report, there also it will show you what is the reason behind this violation and how you can remediate it. Right?
Can you remove or override any existing policy as per our custom application?
So these policies are something which are driven through a GitOps way of implementing or applying these policies, right? So definitely, whenever so if you are talking about dynamically changing these policies, no. You have to make sure any changes that you are doing in a policy has to be driven through a GitOps way, right? Where you commit this, you test it, and then you apply it in your cluster, right? The dynamic policy should not be encouraged because definitely it will introduce more unknowns to your system, and you will definitely struggle more to understand what actually happened in the dynamic changes, right? So that's where we suggest you should go in a GitOps way of implementing all these policies and define these policies in a central repo where all the policy sets are defined, and you keep on changing in that through a version control only, right? So that it can be tested and then only it can be deployed. Otherwise, directly making any changes, we do support a temper prevention where you can't actually go into your cluster and change something in your policy. It will revert back to its original state, right? So you won't be able to actually temper any policy in the runtime, right? So all those things can only be done through a GitOps way of implementing this, right? So no temper can actually happen in your cluster, within your cluster.
So is it an option that whether I want to remediate it or not, or you are not able to do it?
No, so automatic remediation is not there. You have to take an action on top of it. It will just show you what remediation you can do, right, and what all changes you can do, but the remediation should have to go through a GitOps way. So that's where the automatic remediation is not happening, because otherwise it will be a state which is not stored in a version control, and then again once you redeploy it, it will get reverted, right?